Hi, this is Scott. I really appreciate our sponsors because they make the show possible. Today's show is sponsored by Developer Express. Become a UI superhero with Dev Express controls and libraries. Deliver elegant .NET solutions that address customer needs today. By leveraging your existing knowledge, you can build next-generation touch-enabled solutions for tomorrow. You can download your free 30-day trial at dx.hanselminutes.com. That's dx.hanselminutes.com.
From hanselminutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 428. In this episode, Scott talks with Matt Barrett from Adaptive Consulting about creating high-quality reactive user interfaces for the industry.
Hi, this is Scott Hanselman, and this is another episode of Hansel Minutes, and I am talking with Matt Barrett from Adaptive Consulting about an application that they have open source called Reactive Trader. Thanks for chatting with me.
Hi, Scott. How are you?
I'm lovely. This is really interesting. I love it when people approach me and they say, hey, we put a whole pile of code on GitHub that we learned from, and now we want you to learn from. And, people email me a lot and they say, hey, we've got some code we want you to take a look at. But this is more than that. This is, not just a little library you put together, but you've got a back end and a website and WPF, and you're working on a Windows Phone version. This is quite a lot of work that you're giving away here, Reactive Trader.
Yeah, it's a bit of an investment, I guess, from Adaptive's point of view. We really wanted to showcase event-driven user interfaces in particular, but more so the stuff we've learned over the last 5, 10, 15 years building push-based user interfaces and what that means.
Mm-hmm. So push-based, I guess I think about, like stock trading and the prices are being pushed out from the server, but I've always assumed that using, commodity web technologies, that's been faked. It's usually refreshes or polling. That all changed, with the idea of push over HTTP.
Yep.
How did you do that before, and how is that starting to change in the industry?
So there's been a lot of different techniques being cobbled together, I guess you could say, by various vendors who have been doing this in the financial services industry since the late 90s, I should say. And they've got a bunch of different techniques that people are familiar with: iframes, long polling, exactly the sort of stuff you mentioned. Mm-hmm. And it's got now to the level of maturity where you buy a product, you use an API, and you get basically a what looks like a socket to you that can push things at you. And underneath it, the technology will be trying all these different sort of connectivity means and falling back to the most available one on a per client basis. Because the problem with corporate networks is that they all have very, very old network infrastructure, and lots of these routers haven't been rebooted in years, and WebSockets don't work. And probably will never work. So these guys have got this really strong background and a fallback of technologies going all the way back down to like iframes and all sorts of horrible stuff. It's slower, but it works, and it lets you, as the application builder, kind of abstract out the underlying technology so you don't have to think about it and you can just use it for its benefits.
Mm-hmm. And has SignalR simplified a lot of that? I mean, you could go to a vendor and say, here's their server-sent events implementation, but is SignalR mature enough, do you think, that it could be used for an app like this?
Yeah, I think so. We had a lot of success with it. It didn't cause us any problems. We use it in a pretty naive way because we know that relying too much on the features of one particular middleware, we call these things middlewares, which means different things to different people. But in our lingo, it's the software that sits between your client and your server and lets you get messages between the two. And we know that relying too much on any one particular functionality of a particular middleware is going to cause you pain when you need to either move to a different middleware or start doing things that are a bit exotic. And in this stuff, exotic is bad and simple is good.
Mm-hmm. So when I hit this at reactivetrader.azurewebsites.net, this is kind of the online demo site. I'm seeing a board of buying and selling and prices, and everything is moving, and you've got kind of fake data going from place to place. You refer to this as a soft real-time system. What does that mean, soft real-time?
Soft real-time is kind of distinct from hard real-time in that there's no guarantees built into the system about the timeliness of data flowing through it. Mm-hmm. But it's real-time in the sense that you and I are seeing the data the same information at the same time. In fact, if you go ahead and place a trade just by clicking on sell or
so
buy.
I'm going to sell US Japan, JPY.
Yeah, that just came up on my screen. So we're
and
looking
you're in
at
London.
the same. I'm in London, and we're looking at the same stuff, the same data flowing back and forth, the same servers distributing prices and trades to all of the people that are connected at the same time.
I see. So it's almost like it's real time unless it's not.
It's real time unless it's not, and unless it's not is where it gets interesting, and where the stuff we've learnt and tried to showcase in Reactive Trader is what's interesting about it, because the happy paths are the happy paths, right? Everyone, you sit down, you knock out some code, your application works when every system is up and every system is connected, and latencies are low and bandwidths are high. That's fantastic, but these real-time systems that are sitting on clients' desktops where they're making very large financial decisions about whether to sell or to buy, you need to make sure that the user is seeing the correct information. And also you need to tell the user if you know you can't show them the correct information. And that's a lot of what we talked about. We wrote a Reactive Trader originally because we'd been invited to speak at a conference earlier this year called ReactConf, which was some pretty big heavy hitters in the event-driven, I guess you could call it, software development space over the last 20, 30 years, Joe Armstrong and people like that. And we wanted to showcase an event-driven user interface, and we're Adaptive as a financial services consultancy, and we couldn't show any of the applications we build for our clients. So we thought it would be interesting to build an app that showcases some of the more interesting parts of the sort of challenges we face in building these real-time, low latency applications.
Mm-hmm. And were they pretty impressed with what you did?
Yeah, I think so. The talk went down really well. We got a really warm reaction from it. Everyone was very positive, and it was a huge amount of fun. We learned a lot preparing the talk and giving the talk, and I did it with a colleague of mine, Lee, and we had a really good time. So from that perspective, we got a lot out of it, and I think everyone else did too.
Mm-hmm. Talk to me a little bit about Reactive. I've talked briefly with people like Paul Betts around what reactive programming is, and I feel like there's a lot happening. You know, this was something that had existed for a long time, but there's been a hockey stick almost in the last maybe 5 or 10 years where people are starting to realize that for a certain class of applications, this is really the only way to go.
Mm-hmm. Yep. So I was thinking about, because I knew that you would ask me a question of what do you mean by reactive? And for us, reactive is kind of baked into the language of what we do, right? A reactive user interface is all user interfaces. If it didn't react, is it broken? You should probably just turn it off. Mm-hmm. But for us, a reactive user interface is one that needs to deal with very, very large amounts of events, and needs to be able to make sure that if those events go, the rate of those incoming events goes crazy, up to thousands or hundreds of thousands of events per second, that the application doesn't fall over, lets you keep processing, and doesn't start showing you updates from a minute ago if that's not interesting. What we should be doing is showing you the state of the world right now, not what was happening a minute ago when the message first got put into your queue.
Speaking kind of, ignorantly, which is something I'm very good at doing, I can see thinking about event-driven, like there's some data coming from somewhere. I'll just hook up an event on got data and then do some stuff when that happens. And then I can imagine if I'm not able to keep up, I've spent time in applications before where there's suddenly this flood and the application starts going da-da-da-da-da-da and updating itself. And it's like, well, wait a second. What exactly is happening? Are we trying to catch up right now? What is the difference between that kind of classically event-driven from the perspective of an old-time Visual Basic 3 programmer, on event changed kind of thing versus reactive?
Yep. Sure. So for us, it's the thing that's really enabled us to write Reactive Trader so quickly and so easily was using reactive extensions. So in the financial services industry in London, with reactive extensions, RX from Microsoft has been picked up and is really loved. And we started using it about 2010, so pretty early on in its life cycle, I guess, and learnt lessons along the way. And what using that has allowed us to do is think about streams of events, not as an individual event that you're dealing with there and then, which is kind of like you implement the method, get data, and we got a message and we do something with it. But instead think about these things as streams in time. So you can say, well, if we see more than 4 events in a second, we need to do something. Conversely, if we don't see an event for 4 seconds, we also need to do something. And so it's sitting inside a message handler is a difficult place to try and do that. You're starting timers and incrementing counters and doing all this sort of stuff. You tie yourself up in knots pretty quickly. And most of the time, it's so difficult you don't do it because it works fine in the happy path. And so you don't conceive of the case when you suddenly get a burst of 100 messages per second. You don't think about where that data is going to be queued. Is it going to sit in the TCP buffer? Is it going to sit in some background thread coming in off into the thread pool in your .NET process? Is it going to sit backed up on a WPF dispatcher? You just don't think about it. You test and you release and it's fine. But we really can't do that with these sorts of applications. If you start showing people prices that are 5 to 10 seconds out of date and they try to trade, their trade's going to fail and they're going to go to another client, which is not what we want. We want to keep people using the systems that we build. And it just makes sense, really. Google has done a lot of research about how much lowering response time on their websites improves usability and how long people stick with websites and things like that. And it's exactly the same for rich applications. It wouldn't be any different. When you click, you want something to happen straight away.
Mm-hmm. So does the idea of reactive programming formally introduce time, this temporal notion, into what was something that really had no sense of time?
I would say it's a pretty key part of it. Absolutely. Reactive extensions pretty much makes time explicit to you. You can introduce time via the use of schedulers and things, which are an API level thing. But the concept of it is there first and foremost, in that the API is about pushing you something, and that you are not in control of when you get pushed that message, and that message may not come to you for another 5 or 10 seconds. So time is very much a first-class concept. It's a good way to think about it.
Mm-hmm. And you're doing reactive work both in the UI on the client, looking at, for example, the HTML client, but also in the WPF side, and then presumably on the server side as well.
Yeah, absolutely. So when we sat down to write Reactive Trader, we did a WPF app and a .NET Server implementation first and foremost, talking over SignalR, as we've already said. And we used RX on both sides. So the server creates these observable streams and increments and decrements prices, like you can see on your screen here, kind of doing a random walk around or away from some initial values we set them up with, and that those events are put onto a SignalR message bus. And at the other end, we turn that SignalR API into an observable stream pretty much as soon as we can, and then deal with that all the way up through the UI, through the traditional WPF things like a view model and up into the binding engine. And similarly, in the RxJS implementation, we do the same thing. We get called back from the SignalR JavaScript API, and we immediately go into an observable stream and do exactly the same implementation of business logic, this thing that I was mentioning about telling the user if the stream has gone cold. So our observable streams here have an SLA that says they will yield a new price every 4 seconds. Mm-hmm. If we don't see a price in 4 seconds, then one of the little tile that has gone quiet will go red. And every now and then you see one of them flash red, right, which is indicating that that's exactly what's happened. And it's the same code, the same pattern, the same asynchronous pattern that we've implemented in WPF, in the JavaScript version. And also we're now moving into iOS, using Xamarin, and we'll probably keep going into Windows Phone and Android and things like that.
So let's look at that point for a second. You said that when something goes stale, it turns red. Is that a view model? There you go. The Euro Australian dollar just went red. That basically said, this is too stale for me to feel comfortable about.
Yep. We think that if you try and trade on this price, it's not going to work. Mm-hmm. And this is kind of it just went, there you go. There it is. This is us talking. So in the talk we gave at ReactConf, we really wanted to highlight a couple of things. And one is that it's important to make technical failures business events, because it's building reliable distributed systems is very hard, and the industry is struggling to do it. But we don't have to admit failure if something goes wrong. We can always kind of step out of band with the technical problem we have, and maybe flash up a phone number for someone to call. So if the price goes stale, we flash the screen red, but in a real system, we'd probably set a phone number up so that someone could ring up and try and get a price over the phone and do a trade if they really felt they needed to. So this means that from the client's perspective, their system didn't go down. The client was still able to trade, which is perfect, which is exactly the sort of thing we're trying to do. And thinking about reactive systems, they're ones that respond to events. And in this case, there's a failure somewhere, and we don't want the system to turn off. The system as a whole needs to keep going. So it responds by prompting someone with the phone number, and they can go and make a phone call.
I'm looking at the RxJS, and I guess I'm a little bit spoiled that I assume that a JavaScript library will just have kind of one JavaScript library, and you say, here's the model, include this, but they've broken RxJS into quite a few things. I would have to say for the uninitiated, it is a little overwhelming. There's rx.all, there's .lite, and then there's a whole series of binding and join patterns and testing and virtual time. Why is it broken up like that? And what did you use, and why would I care?
That really comes from the reactive extension style of giving you only the smallest amount of API surface area that you need, which is good when you're a power user, but you're right, it's a bit intimidating to begin with. And I would suggest for people just starting off, use everything and just play around with it. Look at the online videos, figure out how you build these apps. There's some great tutorials out there. Have a look at Reactive Trader, see how we plug everything together, and then realize that most of the stuff you don't need, and not all of it sits at the same level of importance. So once you've got a bit of a mental model about the stuff, it's quite easy to discount and not import the things you don't want.
Okay. And I noticed that one of the things that's important about RxJS is that they unify all the different sources of information. It's not just, in this case, a data stream. We've been talking about trading and this finance data stream, but another data stream might be evented data like the keyboard or something that's happening in a web worker. Is in the world of reactive, is everything a data stream, from my mouse moving to something going on in the data?
Absolutely. Everything is a stream. And that's one of the things we really highlighted in our talk, is that when we picked up reactive extensions and started using it to deal with streams of data like prices and trades appearing in the blotter and stuff like that, it's very natural. But it became so natural to us that we also started seeing streams where before we thought we were seeing just request response. So for things like loading configuration data when your application starts up, like loading a set of users you're entitled to see or something like that, we traditionally think of those as request response. But actually, if you think about them as request, tell me what the set of users I can see now are, and then keep telling me about it all the way through while I'm running, that's really powerful. Now you've got an application that if configuration changes, it will reconfigure itself. Why do we want to be telling people to turn things on and turn things off again just to refresh to get the latest set of accounts? So we really think about all network calls that we make to backend services, to APIs, whether to a REST API, for example, we would want in future for it to just give me back the answer now, and then all the answers in the future whenever something changes, as long as we're still interested.
See, now that's really interesting, because that takes what I would think is a traditionally very hard problem, like the kind of the classic configuration changed event then would involve, for most applications, the nuking of all configuration and then reload from settings. I mean, I know we've all written that code before.
Yep, absolutely.
You're saying you would completely change your way of thinking, your perspective on that.
We would completely. We can't really do that for these sorts of financial services applications. If a regulation or some client exceeds their credit limit, or there's some business event that happens during the course of the week, we're not in a position to say we're going to call up all our clients and tell them to turn their app off and turn their app on again. What they will do is go and use some other bank's trading application, because these guys have no interest in our problems. They're trying to solve their problems. We shouldn't be forcing our problems onto them. So we very quickly learned that we have to be able to push configuration changes, permission changes. So maybe one of these currency pairs you're only able to trade from Monday through Wednesday, and on Thursday and Friday someone else is able to do it. Well, we don't want you turning your app on and off to get the latest set of things you can trade. We will push you a bit of data that says you can no longer trade Australia US dollar, and that will disappear from your screen. So that configuration is a stream.
And do you think about it that, like, it seems like layering, while important in programming, is super important in this. Like, I assume that your user interface has no concept of where this data comes from. It's all,
Absolutely not.
The idea of view model and MVVM extra important?
View model is a well-architectured view, and view model is extra important, because you need to be able to reason about the different parts of your application that are susceptible to these events that will occur sometime in the future and require you to make something disappear or reappear. So it's very important to understand the life cycle of your application and how you will be turning various features on and off in response to these events. Mm-hmm.
So the idea of a view model and then some client data binding that's automatic is important. What are you using in both these applications? You've got a WPF app and you've got a HTML app. I assume that the data is streaming in, and then the reactive code that you've written is acting upon that, and then magically the UI gets updated. What does that part?
So in the WPF app, we don't have a lot. We're pretty confident with WPF. It's a fairly large bit of the software landscape in the industry we work in. So it's pretty straightforward. We just have the Reactive Extensions API, an observable stream that comes all the way up. The view models that we write, subscribe to them and assign it to the properties, and the binding engine takes care of the rest.
Okay, so using the standard WPF binding engine works great.
Standard WPF binding engine works great, nice and lightweight. Everyone understands it.
Right.
It's easy to reason about, and we don't like the idea of putting a lot of complexity into some special source of the application. The stuff is complex enough as it is.
Indeed.
And we like to see everything be done explicitly. To talk about the JavaScript app, let me just, Olivier, what did we use for JavaScript? And we can edit this bit out and I'll knock it up. So for the JavaScript version, do you want to re-ask the question? Because I didn't know.
No, that's okay. I usually just keep rolling. So what Matt has done is he just kind of turned his head to one of the other developers, Olivier, and asked the question. So you're using Knockout
We're
JS?
using Knockout, yeah, exactly. And the same style from underneath that. So an observable stream comes off the SignalR API up into the UI, and we just bind to the Knockout.
And it's interesting that you're using that, because for people who are WPF programmers or formerly Silverlight programmers and are really deep into MVVM, Knockout is an extremely comfortable place to just kind of drop in. So you really kind of ported, didn't you, from WPF?
Yeah, we used TypeScript and ported from the WPF implementation that we did directly into TypeScript. In fact, Olivier did that over the course of, I guess, a week or so, and he's amazed that it's basically a line-by-line port. And the binding engine that Knockout provides is very similar to WPF. Maybe it's a little bit better because it's a bit more modern, a bit more lightweight. HTML and CSS is a very good rendering toolkit, and it's very fast.
That's interesting that you use TypeScript. I joke in a talk, but as with all jokes, there's truth, that TypeScript is what a C# programmer wishes JavaScript was.
Yeah, absolutely. So we've done work in HTML apps and WPF apps and all sorts of different things over Adaptive's history, but our own individual careers as programmers. And one of the things we've been struggling with a little bit is how to build large, applications in HTML and JavaScript when you don't have inherent structure in your development. So if you've got 10, 15, 20 developers building an application that has 5, 6, 7 different functional components, and you know that the investment is going to last for 5 to 10 years, you have a very large concern about code quality from day one, because you know this stuff is going to be around forever. So you want strong typing, you want structure, and TypeScript enables us to get all those things and kind of opt in and opt out of JavaScript when we want to, but overall have a really nice structure for how we build our applications.
So that idea of strong typing, that safety net, was important because you're in finance?
No, not because we're in finance. It's because the scale of the applications we know are large and aren't going to go away.
I see. And
that the developers are many and varied who will be working on the project.
I see. So compilation, I like to say compilation is the first unit test. It was this safety net that was what type safety offered you.
Absolutely. And the ability to refactor and be confident that you've caught all the places where you might have broken a contract is very important.
And at the protocol layer, jumping back down to the protocol layer, your WPF app and your JavaScript app both talk SignalR to a backend reactive server, basically. And they speak the exact same thing, and you move right off the wire into the internal message bus quickly as possible. So the SignalR is really at the lowest level, and it's
So we're pushing JSON back and forth across SignalR, and the common path. So these prices that are ticking, which happen many, many times a second, we've optimized that JSON down to use the sort of optimization you can do with JSON, which is just use shorter strings. The next step would be to rip that out and have a binary representation. And then the next level of sophistication after that, which we haven't got to in Reactive Trader, and I don't know if we will, is to send just deltas. So just the parts of the message that change that fully describe a price.
Assuming that the network latency and the size of the message in the network is in fact a problem.
Sure. So we find that even though a lot of the clients, people are sitting in very nice high bandwidth environments, there's still clients in Vietnam who are important people who are sitting on the end of a very long line of copper, or maybe not even on copper, maybe sitting on a 3G or 4G connection that their whole office is using. And so we need to be very conscious of the amount of data we're sending over the wire.
Mm-hmm. So then something like BSON or binary JSON might be a future optimization, and then a delta over binary JSON.
Absolutely. That's exactly the sort of investigation we would do. And we need to be very sympathetic to what the middleware is doing. So we'd need to look into SignalR and see how much headers it sends with each message. Maybe there's something that we could use more closely to get it to work nicely all up and down the stack.
Yeah, and definitely it's interesting when you're optimizing things that things are getting so tight right now that the size of the HTTP headers may in fact be larger than the body.
Absolutely.
So you really want to optimize. With WebSockets, of course, once you start that connection, and you can be just a few bytes.
Absolutely. So we would move to WebSockets as quickly as possible. And in fact, Reactive Trader starts up, downloads JavaScript, HTML, and CSS from the website, and then switches immediately over to a WebSocket connection. So there's no REST API behind any of this. It's all WebSockets. Mm-hmm. All of them are WebSocket service calls. And that's the way we think everyone will be writing these applications in the future, because once you have a connection running, you don't need to go about and doing that TCP handshake all over again if you've already got an active connection and a duplex pipe that lets you send things back and forth really easily.
Now, you did your Windows app in WPF, and I think WPF sometimes gets a bad name just because there haven't been a whole series of updates to WPF. I'm curious why you didn't do a Windows 8 full screen app, and what your opinion is about WPF for this kind of app.
Sure. So we actually do have a Windows full screen app. Once we've written the WPF app, which was kind of our bread and butter and where we went first, we started porting it to other platforms. So we've got a full screen Windows Store app, and we're just waiting to do the last bit of the last 20%, which will probably take quite a while to get it up onto the Windows Store. And we've also started porting to iOS using Xamarin. So we're C#.NET devs first and foremost. Although Adaptive as a consultancy has sort of the full gamut of technologists working for it. But we wanted to learn more about Xamarin because we see it's expensive if you're someone trying to get an app onto Android and iOS and Windows Phone to rewrite all those different parts of the application over and over again. And it seems like Xamarin offers a really good solution for this.
Yeah, absolutely. And it's very familiar. And the idea that SignalR is available on Xamarin, and while you don't have WebSockets directly on iOS, you can get really, really close to the same programming model.
Absolutely.
And you threw it up on Azure. It's up on reactivetrader.azurewebsites.net.
Yep.
So hopefully people will be able to play with it up there. What are your plans for the future? You're going to put store apps in, so you're going to have basically 4 different
store apps, yep. iOS, Android, Windows Phone to begin with, and we'll keep going. And then we're going to try and pull all the content together into one place and kind of try and improve the story about event-driven user interfaces and event-driven programming, and document more our mistakes, I guess. We've been doing this stuff for 10 years. We've made a lot of mistakes, and it's fun to talk about them and share what we think is best practice. Mm-hmm. And also have the conversation. Financial services isn't a secret place, but because of the concerns about IP and how people don't like to talk about what they're doing, people don't get to see these sorts of applications. And why not? They're fun. It's a cool technical challenge to think about this sort of data and this much reactivity. And I think we'll see more and more users wanting this sort of responsiveness in their shopping carts, right? Why shouldn't, if we're both logged into a website, why couldn't I put something in your cart and you put something in mine and have it appear straight away? That seems like a fun thing for software to be able to do in this day and age.
I think the other thing that's so nice about this, and it's so generous for you to release such a large amount of code, is that it's real, it is non-trivial, and
Absolutely.
It's really very tidy. You know,
yeah.
As code looks, it's like there's a little imposing. You go, wow, my goodness, there's like 9 projects here, but it's very clean, it's very well factored, it's very, very organized, and it's very easy to follow. And I noticed also one of the things that was kind of interesting is that you dropped some link pad example queries into the source code as well.
So this is us taking reactive and event-driven programming to kind of the next level, I guess. So reactive domain models are something we've started building, and it's something that we're getting a lot of traction with. So this is the idea that we're all kind of used to, or we're starting to become used to, asynchronous service calls. Mm-hmm. So you make a call, you get back an observable or a task, and you know that the result is going to come sometime in the future. But we still have, I guess you could say, synchronous domain models. So customer.name, .last name, all this sort of stuff. But
right.
actually what's underlying that and is an observable or reactive domain model. So that's what you can see in that linkpad script, where we go off to the back end and say, give me all the currency pairs that I can look at. Find me the Euro USD currency pair. Give me the price stream on that currency pair. Tell me when the price is above or below a certain rate, and then execute an order. And that is 5 lines of query comprehension syntax in a linkpad script, and it reads and does exactly what it says. The business users can read it, but all of it's asynchronous, which is pretty cool. And that's that level of asynchrony and being able to embrace it and use it for even the most trivial of trivial parts of your application, whereas before the complexity of the asynchrony would be something you'd say, oh, I'm just going to block here and not worry about it. I don't have 10 days to do this properly. I need to get the job done. Now you can just put it everywhere and use it elegantly, and it leads to really nice APIs. So if you are, I would really encourage your listeners to download Reactive Trader, open up Linkpad, and just start playing around with the API that we've got, that we've built the application on. And they can go and write a command line Reactive Trader in probably an hour, I guess. They could list out the currency pairs, pick one that they want to trade against, just update the prices into the console, hit enter when they want to buy or sell. That's pretty cool. The API is going to lead them down the road of success, get them to fall into the pit of success, I guess, because the API will only expose the different operations they can perform when they've got the right data and when everything's in the appropriate state.
I think there is a challenge to the reader right there, to the listeners. Yeah. I want to see an ASCII art version of Reactive
absolutely.
Trader. We need to get that done ASAP. And I have to say, it's very well factored. And I think your point of being able to go and write queries over the top of this API, with respect to Arthur C. Clarke, I like to say that any sufficiently well factored layer of abstraction is indistinguishable from magic.
Yeah,
and
absolutely.
You've definitely pulled that off. Thank you so much, Matt Barrett, for chatting with me today from the folks who made Reactive Trader, Adaptive Consulting. I'm going to put links to everything in the show notes. You can go and get this at GitHub/Adaptive Consulting. There's a video. There's a complete walkthrough. It's fantastic stuff and a really, really great way to learn Reactive. So thank you so much for your time.
Hey, no problem at all.
This has been another episode of Hansel Minutes, and we'll see you again next week.